should be on. Cool. Sam, you can go. Hi, everyone. Welcome to DevSecCon London. Thank you for everyone in the room who's here today and everyone online for joining us. We have some great sessions coming up in a few minutes, but I just want to remind everyone who's online, please remember you can ask your questions in the chat and we'll get them over to the speakers. Everyone in the audience, also, we'll get some speakers over to our, some questions over to our speakers soon. And just a small reminder that on the 27th of June, we are hosting DevSecCon 24. It's a 24-hour live stream event starting in APJ and working our way right around the sun. Different content, no double speakers, fun prizes. You can win a Switch in every single region. So come along, have some fun. You can find everything on DevSecCon.com. But without further ado, I'm going to hand over to Matt, and he's going to tell you everything he knows.
Thanks. I'm going to take a long walk now. Check. Is this? It looks like it. Probably just going to say 10 questions. Oh, is it a... Good morning, computer.
Everyone online, we're having technical difficulty. We will be streaming it.
You can see us. This is a miracle, but not see ourselves. Yeah, well. then go into more modern incident response techniques, but still talking about more traditional hardware, more traditional networks. So this is your intelligence-driven defense, sort of kill chain model, and some automation around it. And then we'll talk about how this applies to cloud native. So what the cloud native technologies are that are relevant, and looking at this incident response in a cloud native system. And then we'll walk through a response to a hypothetical, to a log4shell attack, but through a hypothetical log4shell attack, because demoing it is like immensely complicated and it's just in terminals all the time. So it's easier to present the information on slides, I think. Okay, so incident response 101. What is an incident? If anybody's ever been on call, done any kind of sysadmin work, this will probably be familiar to you. Formally defined as an event that could lead to the loss of or disruption to an organization's operations, data, services, or functions. Right. So this is an outage. This is something that happens to our systems that's got a detrimental effect on their availability, their reliability, the durability of the data, the privacy of the data, like any of those kind of non-functional requirements that we talk about. A security incident specifically, there's another formal definition here, but I think you sort of intuitively know it's an attack, it's a compromise. It might, the modern attacks, right, are like get in, use the compute for crypto mining, get in and extort the organization, threaten to wipe their data, get in and extort the organization to exfil their data. So this sort of hack and leak, the modern ransomware kind of stuff. Yeah, that's what's in the news at the moment. But yeah, as I say, we kind of probably intuitively know what a security incident is. So what's a response to one of those incidents? Well, it's, again, you might sort of intuitively understand it, but we can talk about it more formally as a like intersection of a set of people, the processes they use, the technology they use to identify these incidents, these attacks, to contain them, to eliminate them, and then to recover from them. We'll go through all of those steps. So what more specifically are we talking about? So in the people, we're going to be talking about your kind of security analysts, folks who do this, security engineers who do this day in, day out. We're going to be talking about the forensic specialist, and this is a pretty magic job, and those people are pretty powerful. They know a whole load of stuff. And then there is a management element as well. This was a little joke with Francesco's. He had something sort of dour to say, but basically say that it does involve the whole organization. You do need management buy-in. Managers, a good manager of a security team probably has a lot of security knowledge themselves and can help out with organizing the people side of things in a response. Your process would be things like defining runbooks, so defining, emergency procedures for what you're going to do up front, making sure the right threat intelligence is understood and is in the right place at the right time, isolating assets, putting up some barriers before you get attacked, and then gathering evidence during an attack, and the important part of an incident response is actually communicating to the stakeholders, keeping them updated as we're going. So what technology are we talking about? So there's sensors to detect attacks. These are your more, sort of traditional EDR and NDR kind of things, network sniffers, antivirus plus on the endpoint. The Snyk offices, I probably shouldn't call it antivirus plus, but you know what I mean? And then more cloud native sensors, things like Falco or other manufacturers' products are available, or reading CloudTrail logs from a cloud or VPC flow logs or something, which were, these kind of things weren't really too easy, too possible in traditional infrastructure. You could maybe take a network tap in certain places, maybe Cisco ACI offered some of them, but these things, although they sound bread and butter to people who've been in the cloud native world for a while, they actually weren't possible earlier, which is why we called them out. And yeah, a lot of that basically looks like log collection or collections of it, collecting events, correlating them, processing them, applying AI these days. Scene would be the piece of tech for that. I'll come on to what that is. And then the big part of this is about automating it, because these runbooks are long, they're complicated, they're error prone, and you actually want to move in real time or ahead of the attacker. So we'll talk a lot about automation of this stuff as well. So this was the point in the talk where Francesco had gone through that with his hacker hat on, and I said, stop. This is all too complicated. Like, explain it to a simple dev. So a few terms that are going to come up when we talk about an indicator of compromise. This is a broad term. This is a kind of horrible term, really. It's very broad, but it's any artifact you can get hold of that points to the attack. So either the payload that's causing the attack, like magic string that's causing the buffer overflow, or some evidence that the attack has, is taking place. So maybe a syscall profile or a network traffic profile for a workload that's been owned. When we talk about a SOC, a Security Operations Center, we're talking about people sitting with eyes on glass, basically looking for these security events to be coming in. In a bigger, more mature organization, you may not have this in your startup, but in a bigger, more mature organization, there will be a room with people sat 24/7 watching essentially CCTV, right? Watching these event logs coming in. The software they use to do that is called a SIEM, which is essentially your event, log event aggregator. It's got some simple rules to pop up alerts, and it's monitoring all of these signals, which is any security related like information channel, like your network logs. And then there's another piece of software called a SOAR, which is essentially a workflow engine. So this is essentially automated runbooks. So you can respond to the signal, see the alert, decide you've got an incident, and hopefully press a button to get an automated runbook to go and respond to things. But we'll talk about why that's not so hunky-dory these days. So what steps do we go through when we respond to an incident? This is not a wheel we need to reinvent. A few people have had to go at code-defining this and writing it down. So the two most famous are, I'll start with the SANS one, and they say you should prepare for the incident, right? I mean, very vague and broad, but you should prepare. You need to identify the incident. You need to work out you're being attacked. You then need to contain that incident. You need to eradicate it, and then you need to recover from it. And then, importantly, you should have a retrospective, realize what went wrong, make sure it's not going to happen again. NIST, and actually the NIST is the one we're going to look at today. The NIST one is kind of the same if you squinted it. Again, it talks about preparation, detection of that incident, analysis, or detection of the signals that might point to an incident, and analysis to say whether they're real, and filtering that down to a more minimal indicator of compromise that definitely are 100% is sort of necessary and sufficient to match the attack, if you see what I mean, and then containing it, eradicating it, recovering from it, and having a retrospective. So again, just to go through some of these terms, because they're from a slightly different world, US federal government, old school incident response, they don't all make intuitive sense maybe to a software engineer. Detection is that watching for signals in the scene, having eyes on glass or waiting for an alert to pop up. Analysis is looking at that alert, because the alert says, hey, there's something suspicious here, go take a look. Like high jitter or something like high latency, something that a software engineer on call might look at. Doesn't necessarily mean, it might be a network blip, right? It might not be your service starting to crash. So you've got to look at these signals, work out whether this is a real incident, and then fetch the indicators of compromise if it is. So it's either the payload that's being used to do the attack, like the magic string that's being passed incorrectly, or evidence of the attack being in progress. And then you usually want like a checksum of it. So if you're talking about strings in a request body that are going to cause a buffer overflow, what you actually usually need is like an MD5 sum of that, because that's what you're literally going to give to the firewall and say, yeah, if you ever see this hash in a block, then you should drop it on the floor. Containment, when they talk about containment, what they mean is preventing further attacks. So limiting the blast radius of this attack. Because what you don't see, and what I didn't see in this when I first looked at it, was like, where's kill? Like, where do we stop the attack? So that comes under the umbrella of what they call containment. So if you think about containment as stopping the attack from going further, well, you're stopping more things from being attacked. So, when do we actually change the firewall rule to block the IPs that are attacking us? That's actually containment, right? Because the model is you've had one thing popped, so to prevent a second thing being popped, you just need to block the attack, right? So the attack might continue through lateral movement or escalation. We can talk about that, but it might just continue from the outside. If you've got 10 copies of the same workload, if you can own one, you can own more than one. So containment would be about actually blocking the attack and also preventing that lateral movement. And then eradication is coming along and cleaning up the ones that we know have already been compromised, so turning them off, scrubbing the disk, right? Recovery is then about getting back to normal service, and we'll come back to this, but this is interesting because it kind of assumes that the service was disrupted in a way in the previous steps, right? So containment is let's block the attacks and nothing else can be attacked. Eradication is we think they got into the BIOS, right? So literally, for the sake of argument, rip the machines out, throw them in the bin because we can never trust them again. Okay, well, I used to have 5 servers serving this application. I've now only got 2 left that I haven't thrown in the bin. So recovery is buying 3 more servers and installing the software on it, right, in a very old school way. So what I've talked about is sort of reactive, event-driven. We an alarm goes off. Oh dear, we've already been attacked. Let's start doing something about it. This didn't really keep up with with motivated, persistent, sophisticated attackers. So we have to move slightly beyond that into this more proactive, sort of interactive incident response. And the way this has mostly been done is through this idea of a kill chain. So this is kill in this sense meaning attack. So what is the attack chain? What is basically the state machine? What is the set of steps that the attacker is going to go through to compromise our system? And we can be more proactive if we can then have a plan to kind of head them off at every pass, or if we can get we realize something's going on and we can get an idea of which state they're in, or we can jump straight to the prevention, closing the gate in front of that step, because there's no point in closing the gates in front of the steps that they've already gone through. So like the slide says, it's no longer sort of purely reactive, and it starts using behavior-based detections and all of this stuff to get like a step ahead, to keep up with the adversary or get a step ahead. So a kill chain, this is your classic sort of cyber kill chain. So read attack chain. So this is the steps that an attack would go through. You do reconnaissance, right? Oh, that port's open and it's running unpatched Java. Okay, unpatched software X, which I know is Java, and I know it's got a vulnerable log4j in it. Weaponization, okay, let me get a curl script, like an mmap plugin that delivers the payload. It doesn't have to be that difficult. Delivery is, well, I'll send it, and I probably want to do that through Tor or some obfuscation, or DNS reflection or something, right? If I'm not being completely stupid. Exploitation is cool, that worked to kind of pop me a shell. And then installation is, well, now I've got my shell, I'm going to download my actual malware. I'm maybe going to privilege escalate, get my malware in the right place. Then that thing can reach out usually to a command and control network, so it can take orders from a control plane, and then we can actually perform action on the objective. So the control plane, when we've got this malware installed in a bunch of places that we've compromised, the control plane can then go and tell it to go and do whatever it's going to do, encrypt the disk and send a ransomware email. All of those stages, there's a million ways that we can do all of those stages. So understanding what all of those things could look like, all the different ways that installation can be done, and therefore sending out the right kind of alerts to find them and knowing what the right kind of responses are to them is very complicated. So again, this is something you don't have to do the research on because there's already frameworks out there. So the famous one here is you pronounce this MITRE Att&ck, but the famous one is MITRE Att&ck, which is a list of all the different stages. You have to squint at them a bit to see that these stages kind of match the kill chain. They mostly line up. They come from slightly different organizations. So for each one of these stratagem is probably a better word. For each one of these stratagems, for each one of these states in the attack, what might reconnaissance look like? What might the adversary do? So this is about understanding the adversary, and then you click through to it, and it's what might we do about it. It's really hot. Francesco wanted to get the slide in. I'm not going to be able to do the justice he did. I can't do the dancing. But this is the point of this is about knowing your enemy. This is about this was kind of a movement from security, as I say, being a purely reactive set of people who understood our infrastructure, but had never tried to attack anything in their lives. Even in a sort of lab environment, really didn't know what that looked like, and just knew what the system looked like in a good state, knew what was wrong, and knew how to turn off the bits that weren't looking right. Going from that to actually understanding what the adversary's motivations are, what they're likely to do, given they're here, where are they likely to go next. So Francesco's got your Sun Tzu Art of War quote about knowing your enemy, and from there we obviously vote Rage Against the Machine. I should have worn the t-shirt today, but I was going to say it's all black, so it's this one. Okay, so I've said we kind of moved, and that already seems quite complicated, right? And it did. It became kind of unmanageable, especially as the adversaries became more sophisticated, and they had all of these tools at their disposal, and they'd automated them. We then had to get into the state of kind of automating as well. So I've mentioned the SOAR before. This is like a tech stack. Think of it as a workflow engine, but they can be quite complicated. This is a tech stack that enables us to feed in the data we know about the attack, and then run an automated response with little or no human assistance. So as I say, think about an automated runbook system. So, security section over. I think we're about halfway through. That's good. As I say, apologies to everybody whose job that is, but hopefully I didn't butcher it. So just to recap, security incident response, it's complicated. Your reaction time is now critical, especially as your computers and networks are very quick, and your adversary is sophisticated and has automated their side of it. Technological interoperability can be a problem. I'll come back to this, but the spoiler is, your SOAR is this workflow engine. You program it in this DSL, usually tell it what to do, so it might know how to change a firewall rule on a Fortinet, but it probably doesn't know how to go and kill a deployment in a Kubernetes cluster because it's just out of date, right? It's just not done the cloud native thing yet. So silly interoperability, things like that could be a real issue. And yeah, the automation can be limited in terms of the expressiveness of that DSL or the kind of systems it can talk to. This gets even worse when we try to apply these techniques and these frameworks, the people, the process, the technology, to security incidents response in a cloud native system, right? Broadly, because cloud native is pretty new, a lot of software doesn't support it. There's a skills gap. A lot of the people don't know it that well, especially the folks who are in security, who don't have a software engineering background. And it's moving very quickly, even if they're very keen and they try to learn. I work in infrastructure. It's a full-time job for me to keep up. So somebody who's actually focused on security, it's even harder for them. And actually getting observability right can be really hard. Like, we love the observability of cloud native systems, but it doesn't come for free. And there's so much information. Often think about what goes into, log server or Prometheus server in an average cluster, that actually sifting that in the correct way can be really hard. And we've also got to deal with the volatility, the auto scaling, the auto pod replacement, the auto node replacement and scaling that goes on. And there's been a change of practice in the way that software teams work, right? There's move to DevOps, everything being a pipeline, infrastructure being provisioned by code. We've got different practices and different tools to, I say we, speaking as Francesco, the security guy, we've got different practices to interact with there. But what's good about responding to security incidents in a cloud native system? Well, the platforms are very capable, right? There's a lot of things they can do out of the box. They have a lot of first-class concepts. They have APIs. We're not talking about ESX here. We're talking about Kubernetes, Istio. They are built for automation. They're designed to be automated. They're very easy to automate, so that gives us a lot of levers to pull. And a real win that a lot, I'd say the vast majority of folks now have adopted is GitOps, right? I won't go through what GitOps is. I assume everybody's kind of familiar with that, but it makes the changes that we make if we respond to an incident through GitOps, and I'll show a practical example later. Those responses are reproducible, they're deterministic. You have an audit trail as a free side effect because you've got your Git commit history, which is immutable and whatever. And the high privileges to make changes to all of these things are given to the GitOps agent, and you've already done that, right? You've already threat modeled that. You already understand that. You already have controls around that because that's how deployments work. So we don't have to give some security person who's maybe not so familiar with Kube, we don't have to give them cluster admin access. We don't have to give this SOAR cluster admin access because, like I say, almost certainly doesn't understand Kube. If it's touching Kube, it's almost certainly just literally shelling out, right? Probably running PowerShell scripts. So that's the last thing, again, because I can get fat-fingered. I mean, there's laughs from people who I guess who've been there. That's the last thing we want to give cluster admin to. So GitOps, makes that very nice. The two tools that I said we focus on, specifically Kubernetes and Istio, the particular benefits of Kube are that ability to reschedule and recover applications. These are in a bit of a weird order, but support for controllers, for custom operators. So that's a very broad topic, but very useful. We've talked about GitOps already, and then more tactically, it's got a few useful features, actually, a lot of which have come along recently, which really help us out. So the ability to use a hardened container runtime, and that's become a lot easier recently with the first class runtime class thing, the ephemeral debug containers, and the checkpointing as well. And then when we talk about Istio, the service mesh, well, we've got a layer 7 network, right? So all the traffic that's flying around, that's not opaque anymore. That's more than just a TCP stream. The protocols of everything that's talking to each other, they're passed, they're understood. Application level metadata is being produced, application level policy can be applied. All that traffic is so you've got a sidecar alongside every workload. So all the traffic flows, not just the north-south ones from the internet, but all of the east-west service-to-service traffic are intercepted by these sidecars. So we can do that observability, and we can enforce policy at every single hop, right? So lateral movement becomes just as hard, if not harder, as sort of north-south. It's not as simple as get through the firewall and then you're in the trusted subnet and you're good to go. We can log again at every point. We can log full metadata because we pass the protocol, we understand it, and we can log the body of every request as well. Sounds silly, but without a package sniffer, without a tap port, wasn't that easy before. We can now do this in very targeted way, say just this flow, just the post requests from this application to this application, and we can do, as I've touched on, very fine range traffic control. So we can firewall, we can block something from this source to this destination only with certain HTTP headers set, whatever our indicator of compromise is. So we propose, Francesco and I, that we can change this NIST incident response framework a little bit, but in subtle but important ways, to what we're calling the cloud native incident response framework. So we can add in step 2, this I've got it in bold, this constraint phase, which I'll talk about more. But so this is different from containment, because this is saying, we're still in step 2, we're still in detection and analysis. So we're still in the state of an alarm has gone off. We want to have a look at it and see if it's a real compromise, but it might be. So what we should do is we should contain, previously you shouldn't really do anything about that until you'd analyzed it and determined it was a real threat, because your response was usually turning everything off, right? Or something kind of equally as brutal. Now I'll show that using cloud native tech, we can put the shields up. Was that the White House executive order like 6 months ago? Like shields up? Was that CISA or White House or somebody, right? It was literally like shields up. We could put the shields up, without actually disrupting service. So it's something we can do a lot earlier while we're still doing that analysis. And then I've done a little regex on recovery, because I can show that a lot of these phases that were assumed to be disruptive now aren't necessarily disruptive. So there may be no recovery to do. We might better hopefully we can go through this whole framework without interrupting service. Okay, so what does preparation look like? This was a slide where Francesco stepped back in. I honestly don't quite understand it. I was looking at it today. Does anybody in here know anything about this? So there's a software library coming along that's basically understand Kubernetes, can be run in a SOC. It's created by one of your friends. But yeah, so this helps us prepare. I think this is around ways that we parse and ingest and make sense of all the sensor information that's coming in from Kubernetes, so we can get more meaningful metadata presented to us and more meaningful alerts. I think, but as I say, apologies, don't quote me on that one. So into step 2, into this detection, right? So into the activation of your incident response. So as I say, we've got this sidecar, we've got this Envoy proxy next to every workload that can send all the traffic logs, all the metadata into the SIEM, which can do its usual anomaly detection stuff. All the vendors call it AI these days, but it's doing anomaly detection or whatever it is. And so for this example, let's say we're getting a log for shell attack. We can confirm that something unknown and suspicious is happening. Either something weird is flying around the network, or a workload is behaving in a weird way. So we either think there's an attack being attempted, or we think a compromise has already been achieved. And as I said before, these events could be generated by the cloud native stuff, by looking at your CloudTrail logs or your Envoy logs, but also there's still definitely a place for your traditional sensors like your edge firewalls, your EDR agents, your NDR agents. So this, in the normal way, would so the normal procedure would be to see that this has happened and escalate to a SOAR and do some kind of cloud native response, some kind of cloud native runbook. What does that look like? Okay, so our new step, constraint, is about kind of proactive containment. This is about buying us time to do our investigation and about constraining an attack. If an attack has happened, constraining it, but constraining it in a way that doesn't involve disrupting the whole service, because we're not sure yet. So that I should have a picture for this really, but the mental model for this is we've got a deployment, a Kubernetes capital D deployment, right? So say 10 pods with an ingress route that points to them. So if I'm on the internet and I send traffic at acme.com/orders or whatever it is, then I'm going to be in a round robin fashion, I'm going to hit one of the 10 pods in this deployment. And one of these pods has set off an alarm, right? So one of them is doing suspicious activity, and we think it might have been compromised, right? It's reading its disk far too much. So what do we want to do to that pod that we suspect has already been compromised, but we're not sure? We want to freeze the orchestration of it. We want to make sure it doesn't get scaled down or updated because we don't want it to go away, because we want to do analysis to it, right? Sounds simple, but in this volatile, dynamic world of Kubernetes, we've got to do that. We also want to block the east-west network traffic from it. So if it has been compromised, we don't want them to be able to move laterally. That might sound disruptive, but of course, because this is Kubernetes, we can very easily just spin up a replacement to keep our service levels, keep our load carrying capacity the same, but we want to make sure that this thing is kind of frozen in time so that we can start to investigate it. So what would the implementation of that look like? Well, the easy way to freeze an orchestration is just to remove this pod from its deployment. So it's almost certainly got a label that says app foo. You can just change that label to app foo-compromised or something. It'll then be out of the deployment. It won't get rolling updates, and the deployment will spawn another pod to take its place. And I've literally even put the command here, right, for how you might do that by just patching it. I'm patching app to app isolated. And this is our sort of first cloud native big win. This isn't disruptive to the overall service, because they say as soon as you take that out of the deployment controller, the replica set controller, is going to give you another one to take its place. You're back up to 10. We then want to block the east-west network traffic, right? So we want to stop this thing potentially moving laterally, but we're running VCO service mesh, so we do that with authorization policy, which is the ACL system. You actually need, I haven't gone into all the details in this talk. Some of these are things that are very easy to do. Some of them are actually quite involved. So I haven't put everything on the slides, but this consists of two parts. Like Istio doesn't really model doing this kind of thing. It's meant to model me as a producer, allow listing and block listing who can and cannot talk to me. So we first need to stop any traffic coming in to the compromised pod. That's quite easy. You write an authorization policy like this. We then need to stop any traffic going out of it, to stop, which is more important, to stop it calling other things. That's actually not very well modeled by the API, so you need to go fiddle with a couple of labels on things, change the service account, and then you end up with a policy that looks like this. But yeah, you can peruse over the slides later. So what do we do to those remaining workloads? What do we do to these other 9 pods, right? So they're in the deployment, they're still serving the customer. We don't think they've been compromised, but we're not completely sure, and we think they are under an active attack, right? We think round robin, if another attack payload comes in, another one of those JNDI strings, it's going to hit one of those next. So what do we do with those remaining workloads? Well, we want to probably respawn them in a hardened container runtime, right? If we block their east-west traffic, they're going to stop working. We can't go that far, but we can at least stop. If they do get compromised, if they have been compromised, we can stop them. We can certainly make it much harder to do a container escape, get into the host, some kind of privilege escalation like that. So the obvious thing to do is to respawn them in a hardened runtime. Yeah, why don't we run them in a hardened runtime all the time? Usually just because of the cost, right? The cost in terms of CPU, RAM, and it slows things down a bit. So our overall service to the end user wouldn't be so good. But for now, we're saying that it's worth doing this. It's worth paying that cost, the dollar cost with the CPU and the RAM, and it's worth paying for a slightly slower service to your end user because it's still acceptable and it's still up. So another cloud native win, not really disruptive, except it might be a little bit slower, a little bit more expensive, but it's something we can and I think should do. So how do we do that? In our example, we're talking about gvisor. Again, it's another patch. Runtime class is a first class now, so there's another bit of the pod spec to patch, and then assuming you've got gvisor installed and whatever, and this will do a rolling restart of your app in the hardened runtime. So now analysis, right? So we've got our suspect pod that we think got popped. We've taken it out of the deployment, but it's still there. So what do we want to do? I think the first thing we want to do, well, actually these are in the wrong order. The first thing we want to do is take a checkpoint, because everything else we're going to do is going to be a bit disruptive, and we might break something. We're going to be leaving footprints in the sand, so we might want to have a clean image to go back to. And certainly, if this is serious enough that the authorities, the regulator, get involved, they're going to want to see it before we started mucking around with it. So we can take a checkpoint. We want to, I think, verbosely log the north-south traffic. So we blocked it east-west. We've stopped it moving laterally. But we want to let the attack continue. Maybe more attack payloads are coming in. Maybe there's multiple stages to it. We'd like to, packet log with that. And if it has been compromised, it might already be trying to reach a command and control network. or it might even be trying to already exfil data. So we want to see what data it's trying to exfil. We want to see where the C2 is it's trying to connect to, what it's saying. Can we recognize the words? Are they in a particular language or whatever? Just as an example. And then we probably want to use some forensic tools on the actual. We want to get into this thing and dig into it and work out what's gone wrong. So what does that look like? The verbose logging of the traffic. So I'm including request bodies in this because a lot of attacks, what would be an XML parse error, or I think you can exploit log4j either in an HTTP header or in a body, depending on what you're sending and how it's being parsed. Envoy is meant to be a high performance proxy. It doesn't like logging bodies, like it doesn't have native support for logging bodies. Why would you ever do that? It's a bit weird. But it's very pluggable, so we can inject. You can actually inject Lua into it. There's a Lua script on the internet that does it, but Lua sucks, so we want to inject WASM into it, which is another thing you can do. And I couldn't find a plugin to do that, so I wrote one. So again, some steps elided, but the main resource is this one that tells us to load a WASM plugin, and it points to some WASM blob that happens to be on my file system. Details elided. What is that WASM blob? Well, again, there's a bunch of preamble, but it's basically the body of it can be this simple. You're just calling you're just hooking the Envoy API and telling it to dump everything to the log streams. It's just a bit of Rust. You could do it in TypeScript. You could do it in whatever. But I just did this to prove we can get it working. What else do we want to do? We want to checkpoint the container. So this now exists in Linux. This thing called Cryo, which is checkpoint restore in user space. It's actually meant for more like process container migration, I think, rather than forensics. What you could do with VMs a few years ago, but it does exist. It can be used for this. So as I say, it's in Linux mostly. There's a proposal to support it in Kubernetes. So there's a proposal for there to be, because it's a container. The container runtime has to call the kernel to make, well, not the kernel, it's user space. But the container runtime has to call the underlying system to make it do this. There's a KEP for Kubernetes to expose this through an API, so you can trigger it. At the moment, that's not implemented. It's just a proposal, so you have to go straight to the container runtime. You have to shell it to the host or something. It's supported by the Cryo runtime. I guess Red Hat Enterprise, OpenShift had a need for this. It's not supported by Containerd. It's under heated discussion about whether it should be. There's the PR 6965. Everybody wants to go join the argument. It's very alpha. It's currently, it's not exposed on the Kubernetes API, so it's an imperative thing to do. You're essentially shelling into the host with a -c to do cryo CTL. It's super alpha, it's still imperative, but it is there, it does work. And then the last part of the analysis, these forensic tools. So recent Kubernetes have got these ephemeral debug containers. So, and an API for them. So kubectl debug, I can get another container, I can put it in the same pod as my suspect pod, my suspect workload. So it's going to share a bunch of all the same namespaces in that pod, including the nice thing about debug is it's going to share the process namespace as well, without you don't have to run the pod with shared process namespace equals true. This one particular container will go join the process namespace of the container that you target. So for example, if your malware is really stupid and it's not hidden itself in the process table or whatever, you can run a PS and you'll see the process is in the ephemeral container and the process is in the main container. So we've got, here we've got a real app and we've got, go run malware.go. That's Francesco hacking. Yeah, that's just bad hacking, man, but just as an example. So what do we want to do? Do we want to do any analysis of those remaining workloads, the ones that we don't think have been popped yet? We probably do. They're probably under attack too. Like I say, attacks are probably still coming in. They're being round robined. Again, let's just turn up the network logging, to see everything that's being hosed at them. Because you might get IOCs, you might get attack IPs from that. And that implementation is exactly the same. You can use that same Envoy WASM filter. So we've now got the evidence. We can do our analysis. We can confirm the true positive, right? We are under attack. We have been attacked. And then you harvest the IOC. Again, very hand-wavy thing to do, but essentially, this is the header that's being used to attack us, and this is what's in it, or this is the body fragment, or something like that. Something that's going to go let us identify this thing, lock it down. So on to step 3, what is containment? look like in cloud native? Remember, this is NIST's version of containment, so this is a big part of it, blocking the attack. So you want to reconfigure the firewall, right, or the WAF. Well, we've now got this, as the academic literature would call it, policy enforcement point. We've got our firewall alongside every workload, and it's at layer 7, so it can match HTTP headers and the like. So we can do layer 7 firewalling, like block this user agent, block this, language string or whatever, block this, whatever the basic Log4Shell attack was, right, which was the JNDI string in a user agent, right, because that's the thing that Log4Shell prints. Log4j, sorry, prints. Anyway, whatever it is, you can do with the basic stuff of the firewall, or you maybe need more powerful sort of web application firewall, WAF style features, if you're going to match bodies or something. So there is one for Envoy. It's called Karaza. It's written in Go. It can pass down to WASM. That's how you inject it in, and it reads mod security rules. So like you would inject mod security into Apache to get WAF functionality, you can inject Karaza into Envoy to get WAF functionality, and it actually takes the same format of rules. So yeah, if you wanted to do something like block a body rather than a header, then you'd need that. But again, that's something you can do. And like I say, these are present at every hop within the network, every east-west movement. So yeah, you probably want to go configure your firewall or your WAF to identify these malicious payloads, block them. That contains you insofar as the attack's not going to pop up anywhere else, right, is our thesis, because the attack is now being blocked. So eradication is where we've got that pod that's definitely been compromised, that set the alarm off. We want to go kill it, right? We know something's been compromised. We want to get rid of them. So that the attack can't reoccur. It can't occur anywhere else because we contained it, we blocked it. This is about killing the things that have been owned. So what does this eradication actually look like? Well, for the pod that set the alarm off, you delete it, right? It sounds simple, but kubectl delete pod, because we've isolated it, because we've made it hang around, because it's frozen. And then the recovery step we're saying is, sometimes optional, because this would, block and kill used to be turn everything off, throw all the servers away. Now, or just roll incident response, like roll an OS patch to stop the buffer overflow happening again, roll new software. All of that used to involve turning the software off, often restarting the OS. Obviously with Kubernetes, we don't need to do any of that anymore. So nothing really altered the service levels, right? We had one pod that got compromised. As soon as we took it out of the deployment, it got replaced. And then those other pods, got rolling restarted into gvisor. So there were, again, no interruption to service, because your disruption budget and your, min unavailable, max unavailable and stuff are all honored. And then you just put it back. So there may actually be no, big cloud native win. There may be no recovery even to do. And yeah, what does this really look like? Well, you probably want to just restart all the, I've talked about restarting that one pod that's definitely been compromised. You probably want to restart everything else in case, or the uncompromised or not known compromised workloads. But actually, because we're going to move them back out of gvisor onto being native and fast again, as a side effect, they're going to restart anyway, right? So when I was putting this together, it sounds like a silly implementation detail, but when I was putting this together, I was like, oh, okay, one of these steps is just going to restart them. So kind of box tick, to be honest. So far I've just talked about what you would do, and I've shown, kubectl commands that you might type into your terminal. We've maybe been kind of assuming that a human's going to do this, or a SOAR runbook's going to do it. But I've kind of said how SOARs are not well suited to this. Even if they understand kube, they need enhanced privileges. So what can we do instead? Well, we can automate it in more cloud native ways. So I've written this piece of software. I mean, I've only started. It's a sketch at the moment. But I've started writing this thing called response. So this thing generates the YAMLs, that I've been talking about, and issues the commands. So just a note, it'd be nice if some more of these things were declarative. A lot of what we have to do, even getting a debug container, is kubectl debug, or the same, the equivalent API endpoint, but it is an imperative sort of one-shot thing. Wouldn't it be nice if I could apply, a resource called something like debug container, and then I get one declaratively, and then I delete the resource and it goes away? That'd be great. It would match with, it would read something else, would retry that operation for me. It would mesh well with my GitOps, because I'd have this audit log that I introduced the debug container here and took it away there. But a lot of these things, the deleting of the pods, the checkpointing are not declarative at the moment. So we need to issue a bunch of commands, and we need to generate a bunch of YAMLs that we can apply apply. So response will do that. You basically, I think I've got a screenshot of it. Yeah, so you kind of run it, you give it the deployment that's under attack, and then the specific pod that we think is compromised, that's raised the alarm, and it will emit all the YAML we need to apply. It actually only emits one piece for now, as they say, work in progress, but this one's emitting the enhanced logging YAML, and it would also go and run all of those imperative commands. So cool, starting automation, looks cloud native, because I can run this, I can get the YAMLs out, copy and paste them, check them into Git, and then go from there. But even better than that, we can have even faster, even more seamless. We can run this thing as an operator, and it's basically the same code. So now, rather than running this thing and giving the deployment name and the pod names arguments, I put those into a CRD. I submit that, I put that CRD into Git. The CRD ends up in the cluster, gets read by the operator, and then the operator in cluster is going to go and actually reconcile that to all of those other YAMLs that I need, like the telemetry one we just saw, the Wasm plugin one. So this, fits in with our existing CD pipeline, doesn't require any extra permissions, doesn't need a human thread to commit to Git, doesn't give the SOAR any permissions that it shouldn't have, any of that kind of stuff. And we've, as I said, we've got the full audit log from the Git history. Even for those imperative commands, we've got an audit log that they were going to happen because we can see the CRD that's going to trigger them. And and this thing is an operator; it's a long-lived daemon, so we can do silly practical things like retry those commands. If we can't get a debug container the first time, it'll just try it again. It may sound silly, but if we're under attack, a guy server might be really busy. So this could actually be quite important, because if a human has to context switch to try to do this in the middle of an incident, it's not great. So this is even less finished. It uses the same library code, the same resource generation code, but there's even less of a framework there. I do intend to put a bit of time into it. So this is the new sort of set of responses that we proposed. I've talked about what they would mean in a cloud native environment, and I've shown the practical way to do each and every one of them, and then I've talked about how we could automate them. We haven't built all the software yet, but our initial observations are that it's fast. It can reduce the impact of the threat, just because we can respond so much more quickly. But it's not going to be a one-size-fits-all thing. You will have to think about your workload and how that works. We're hopefully going to build that out and learn some more lessons along the way. I don't think we've got any free books, so I'm going to skip that. We have free books in Amsterdam. Email your nearest control plane representative. They'll get your book. Thanks. I'll take any questions. Lewis. James.
A question about the analysis. Okay. Got a question about the analysis phase. So imagine malware or an attack or whatever does something which characteristically results in something being written to this, so naively writes an SSH key or something like that, but then the pod gets bounced. How do you see the analysis proceeding in this type of circumstance?
Yeah, it's a good question, because that's not something that we automate. No worries. So that's a good question. It's not, we automated sort of step 3 of this. I guess you're talking about step 2. So this stuff that we built is quick, but it can only kick in, if by the time that alarm has been raised, or by the time a human's actually got to it and gone, oh yeah, that's real, and hit the runbook button. If that pod has been bounced for whatever reason, because the attacker was, flat-footed and crashed the app, or just because pods bounce quite a lot, I guess there's not too much like this directly addresses, but it would probably be about leveraging the abilities of all those cloud native platforms and doing the detection phase more quickly, raising the alarm quicker, helping the human out and just helping them get to that yes, no, false positive more quickly. We could maybe move the checkpointing actually into that preemptive containment step. That's actually quite a good point. I guess if any alarm, as long as those things aren't too big, as long as, if any alarm goes off against a pod, the very first thing we could do is take a checkpoint, a disk image, because again, why not? It's not disruptive. And then somebody could look at it offline. That's actually, that's a good idea. I'll take that back.
So the first part of the instance response framework was preparation. This might be an obvious question or answer, but outside of penetration testing or offensive security, what else can you do to prepare for an attack that you don't know is coming?
I need this to give a non-answer, really. That's Francesco's area, or these folks might actually know more about it than me. I mean, to my mind, it's about, I'm a cloud native software engineer, right? So to my mind, it's about security people learning more about cloud native, understanding the platform, like doing the threat model, like literally understanding how to get hands on keyboard and like observe and influence the thing, understanding the threat model, you know, how does the system plug together? How does it work? Where might attackers come at it? I can't say anything more meaningful than that, I'm afraid. It's just not my area, but I don't know if anybody's got anything else. Yeah, threat model would probably be a really good place to start. I don't know, where would they, who's brokering online questions?
Nice. At the moment. But if we have no more questions, then I think we can say a huge thank you to you.
Thanks.
Obviously, anyone in the audience and watching, if you have future questions, you can pop them on the YouTube channel or on our Discord server, and we'll get them over to Matt, and he can answer them for you. But thank you so much. We're going to switch speakers now for everyone watching online. So we're going to put on a quick break intro whilst we get Sonya ready for the next session.
Okay. Hello, everyone. Welcome back. Thank you for joining us again. We have our second talk coming to you now, which is from Sonya, who works at Snyk, and it is on the iceberg. Your attack surface just got bigger, so how to mitigate risks in your OSS projects. And I'll pass over to Sonya now. Thank you.
Hey, hi everyone. I'm going to talk about the iceberg. The attack surface just get bigger, helps mitigate risk in your OSS project. So, what are we going to talk about today? So first of all, we're going to have a look at the current state of OSS. Then we're going to talk about the iceberg, and it might be like this little emoji asking yourself, what is she talking about? But I'll explain what is the iceberg. Then we're going to have a look at the GitHub Marketplace, understand a little bit more how we can leverage the security tools to secure our pipeline. And then I'm going to give some tips on how to harden your OSS projects and a bit of learning and resources at the end. So at first, just wanted to take a step back and define what is open source software so we're all on the same page. So the person who coined the term open source software in 1998 was Christine Pedersen, and she did it as a deliberate effort to make this field more understandable for newcomers and business. So open source software is based on source code that anyone can inspect, modify, and enhance. Also, we think that that many people prefer using OSS for several reasons, including security, because there's a lot of people that could actually have a look at the code, and if there's any security issues, they can participate and raise a pull request to propose some changes. So this is great with open source software ecosystem, but let's have a look at some open source software attacks. So the first one is typo squatting attacks. This takes place when bad actors push malicious packages to registry with the hope of tricking users into installing them. So this is really similar to what you have with website phishing attacks that exploit typos made by individuals who may accidentally typing a wrong address. And here we found an example with the package React, and you can see that there's actually two E's. So you're not installing React, the package, but a malicious package that has a completely different end goal in a sense. Another example is malicious packages. This is when you inject malicious code into a software product or components in order to compromise the dependent systems further down the chain. So in this example, we're having the package called Fall Guys. And usually the malicious actor will try to surf on trends. And in that case, the game was quite popular during the pandemic. So user might think that by downloading this package, they can get an advantage within the game, should be like cosmetics or others. Unfortunately, in that case, Fall Guys was a malicious package that contained malicious code. And in that case, it attempted to read local sensitive files and exfiltrate information through a Discord webhook. So the code attempted to access specific path available on the Windows systems. It was basically looking at the local storage level DB level. One last example is compromised maintainers. This one is an interesting one where malicious actors will use social engineering techniques and methods to gain access to open source projects. So here we have an instance with the event stream package where the malicious actor actually did use social engineering on the maintainers. So what he did, he went through all of the issues and looked if he could participate and push some codes and contribute to the repo. So at first he pushed some cosmetic changes just to build up the trust with the maintainer. Once he got more permissions, he actually pushed his malicious payloads into the code base, and he was targeting a Bitcoin wallet in that case. So the modus operandi was quite interesting for this specific case because it was going through all of the issues, did a little bit of social engineering, just to contribute and build up the trust and then push the code, unfortunately. So this is known as supply chain attacks, also called third-party attacks. And this occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. The bad news is it doesn't only affect the JavaScript ecosystem. This is for all of the ecosystems. And we also had quite a big example with Log4Shell in the Java community with the vulnerability in the open source Apache Log4 logging library, which has heard a severity rating of 10 on the CVSS. So supply chain attacks are quite attractive to hackers because usually when they compromise one component, they can compromise, this can actually produce like a good entry point for them to compromise other parts of the organization. So let's have a look here at a bigger picture with the supply chain attacks and different levels where they could potentially tamper with the applications. At the coding level, we've seen type of spreading. There's also dependency confusions. On the end of the pipeline, we could see examples with KubeCon and SolarWinds. So, for example, with KubeCon, what happened? You might probably have heard of this attack. This happened in April 2021. So, KubeCon is a software company that provides a code coverage tool that is used by thousands of organizations. And the attacker actually gained access to the KubeCon bash uploader scripts, and this is how they could, a user could upload code coverage report to the platform. Unfortunately, the attackers managed to tamper with this entry points, and they were able to steal credentials, access sensitive data, and carry on further attacks. For SolarWinds, actually they had their Orion platform, which was on the back end, that has been compromised, and the attackers managed to have a backdoor to persist access and to compromise their system. And again, it's the same schema. They've actually used that backdoor to exfiltrate sensitive data. So why application security is important in a sense? Well, we've seen that vulnerabilities can originate from something as simple as config error or using a software component that contains a known vulnerability, which is why maintaining and improving application security program is important for businesses, maintainers, and contributors. And you have organizations such as OWASP that track vulnerabilities found, and they provide a list that developers and security teams can use as a starting point for their AppSec program. The latest one was released on 2021 and included vulnerabilities such as broken access control, injection attacks, security misconfigurations, and others. So now that you have a little bit more context around that, let's say hi to the iceberg. So this is the iceberg. Let's all say hi to the iceberg. Hi. So let's start with the tip of the iceberg. Actually, the iceberg is used as an analogy to understand a bit more all the different layers that we have within our code base. So the starting point is our code, the code that our proprietary code that we write in an organization. Does it bring security vulnerabilities in our code base? Maybe, maybe not. So here we have an example where we have a function signature for an express application with the request response and next callback. We can see that is actually calling the user database and looking for the username and passwords. And here we have an example of an express applications that is using body parser to parse the JSON objects, and it will take whatever you put into and convert it to a JavaScript object. So if the request has the username and passwords, this will be part of the JavaScript object. And if you manipulate this request, so in the case of if we're using MongoDB, for example, on the backend, and if we're using the $sign greater than and add the admin as username, it actually, because we haven't sanitized the input, this will allow us to be logged in as the admin. So you might understand that this shows the importance of sanitizing the inputs and to handle this as soon as possible before it's stored into your database. So this is another example here. We're actually importing a dependency, which is a nice segue to the layer below the application code on the iceberg, the open source layer. So if you think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, we don't want to reinvent the wheel. And this is totally understandable, because why we would want to waste some time rewriting something that might probably already exist in the ecosystem that we're using. So that's what we have here with the Mark package. So the Mark package is used to implement Markdown into our code base. But you can see that we're actually bringing several other packages in our code base, all those little NPM packages that you have in this graph. And this increased the attack surface and the complexity of the application, introduced new risks. And we have to keep in mind a few questions. So for example, are we aware of all the packages that we have? Are we aware of all the dependencies and sub-dependencies in this code base? Do we have a good understanding of indirect or transitive dependencies? Do we have tools actually to help us having that visibility? And also, what are the risks when we bring a component into our code base? So I know that's a lot of questions. Let's see a few numbers around that. So we can see that the average number of outstanding critical vulnerabilities in an application, and this will depend on the programming language, but it's usually around 5. And the average dependencies per project is around 80. But the most concerning one is the last one. The number of days it takes to fix a vulnerability is around 100. Let's go back to our iceberg because we have 2 other layers to cover. So, third layer, containers. Because obviously we want to deploy our application somewhere. So we could use containers or a static website to do so. We have different options. We could use Docker, Vercel, Netlify, the cloud providers. So if we're using Docker, we're adding a Docker file now in the equation, which has metadata about our project. Once again, this is an additional layer. So we're adding more complexity and we're increasing the attack surface in our project. Let's take a step back and let's have a look at the really basic Docker file I know, but let's imagine what could go wrong with this example. So at first, with this, we can see the common software vulnerability here with the image magic, for example. They might actually include vulnerabilities. In that case, image magic was a package used to resize image if you want to resize image into your project. Unfortunately, this package was vulnerable to remote code execution, and the team behind the image magic package actually created a website called MITRE Att&ck because they actually list all of this code vulnerabilities that they have for this one. The other one is the dependencies that we're installing are they vulnerable, and we've actually seen them with potentially with typo squatting and others malicious packages that we've seen. Another one is on runtime vulnerabilities. Do we actually take time to have a look at all the security built-in that are released? Probably not. We don't have time for this. Hence, we need to have those tools to give us visibility and to skip those steps. Coming back to the iceberg, what is the last layer? Any ideas? What could be the last one? Yeah. So the last one is actually infrastructure as codes, also the wrappers. So this is an approach to manage data center server storage, networking infrastructure, because you're provisioning your resources through code instead of manual processes. So this to make sure that your application is scalable and available. So your code is your source of truth, where you specify through codes everything that is composing your infrastructure specification in your config file. This is great because you can use version control, you can test, you can monitor. So IAC is amazing, but we do have the first security vulnerability is called misconfiguration, unfortunately, and this refers to any glitches, gaps, or errors that could expose your environment to risk during cloud adoption. You do have a few numbers at the bottom of this slides. So for example, with PlayStation Network, they had 77 million accounts hacked. For Uber, you have 57 million accounts breached. What happened there was that their repo on GitHub went from private to public, and usually malicious actor will actually scrap GitHub to check if they could collect any credentials. This would happen there. They actually managed to get their AWS credits and compromise their GitHub actions. And same number 3, FedEx as well. So now we have a better understanding of the modern application. So we know that the application could only represent 10 to 20% of our code base. And below that, we have 80 to 90% of our code base composed of open source libraries, containers, and IAC, which brings, each of them bring different security vulnerabilities. Hence, it's important to have guardrails at each stages of our pipeline to spot the vulnerabilities, because our attack surface is getting bigger and bigger. And it's also important to actually secure that software development lifecycle. So this would actually include different stages. So you can do it as threat modeling, pen testing, implementing security tools within your pipeline. So you have different ways to secure your SDLD. And also the main reason to do so is because security should be a continuous concern. You also have security consideration by all of the stakeholders in your team, and also to have early detection of flows. And you don't want to fix those and have and you want to reduce the cost of it. So this is usually what you can implement within a company. But the good news is if you are a contributor, maintainer of open source, or if you're working on a smaller project, you can actually implement all of these guardrails using GitHub with all the different application and action which are free for open source projects. This is also a way to give your project the same level of protection as for a proprietary project. So let's have a look with the GitHub Marketplace. So who here is aware of the GitHub Marketplace? Yeah, cool. So the GitHub Marketplace was first introduced in 2016 during their GitHub Universe. So this is a place where developers can find integrations, applications, and also GitHub Actions when they can implement them into their workflows. The good news is covering actually all of the steps within your CI/CD pipeline. So you could find code review, security, compliance, dependencies, and other steps, which is great. So how would you set up those applications and actions? So you'd have a look at which steps you would like to actually implement. So if it's continuous integration, dependency management, and others, there are a lot of tools, and there's every week there's like new tools or GitHub Actions added into this library. But when you're looking at implementing an action or an application within your project, obviously this will depend on your workflow and the team of maintainers and contributors. So it will depend on the tech stack that you're using. What is your workflow? How many steps would you have into this pipeline? So usually you would go and navigate through the product page. This is where you have more information like the description, but also more importantly, and depending on the supporting languages that you are using, you would see that kind of information. Also, you can navigate directly to their GitHub repo and see like the number of it installed, who are the maintainers, having more information and the metadata around that. And most importantly, what's the documentation? Is it easy to implement? Do you have starting points? Do you have some documentation with basic example usage to actually have a quick start with those tools? And as I mentioned, the good news is if you scroll down to the bottom of the page of these tools, it's usually free for open source, not only for the public repos, but also if you're part of an open source organization, or if your project is part of open source, you will get it for free, which is great. So when you click usually on the billing page, you'll see 0. So it's free. That's great. So what do you need to consider? Do you want to install an application or an action? So again, this will depend on the workflow that you have within your team of maintainers. And if you don't have a team, just like by yourself, if you're maintaining a project. So this will depend on your workflow. As I mentioned, what kind of tech stack you're using, what are the programming languages that you're using if you're deploying on Docker, are you using Kubernetes? How many steps do you have within your pipeline? Can you implement guardrails at each of these stages? Also, you can have a look at if you're interested in installing only applications that have the publisher badge, so the little blue tick next to them. And also, you'll think about how many tools you'll implement at each stages. So, for example, for the DevOps pipeline, you might implement one tool for code review, one tool for the code quality, one tool for dependency, one tool for SAST, and you might be installing 2 tools for the dependency management. So, for example, because you want potentially 2 databases to compare and have a wider coverage in a sense. So I would say experiment on that, but most importantly, get the right tools for your projects. And also because the good news is because it's free, so you can actually have a sense of the tool. If it doesn't fit your team or your workflow or your project, you can just get rid of it and try another tool. So how we can leverage security tools to create a basic pipeline and implement guardrails into your open source software components. So you can leverage the security application in action available on the GitHub Marketplace to secure the pipeline at each stage. And we're going to see really basic pipelines. The first one will be the software composition analysis to cover the open source components that you have within your pipeline. The second one is a tool to prevent secret sprawling. So if you catch if there's any secrets or credentials within your code base. And the last one will be static code analysis, just to check if the code that you've actually written doesn't have any security vulnerability. So let's start with software composition analysis. So here you have an example, the definition of Synopsys. So the SCA focuses on identifying the open source in a code base so teams can manage their exposure to security and license compliance issues. You can see there's a lot of vendors that could potentially cover this. Let's take an example with Renovate. So the important thing here is to check the supported languages, obviously, on that. Also scrolling down, as you can see, this is free for the open source public and public repos. And usually these tools, they will raise an automated PR pull request in the sense where you're going to have all of the information on there. So the version where you can actually create the package. So the first time you are installing Renovate, you'll need to configure. This is actually automatically set up. They'll automatically raised. You just need to scroll down and just accept this, and it will set up Renovate, and then it'll start and show you the first PRs if there's any vulnerabilities within your code base. And as you can see, usually you have the version at the top, just to let you know which version you need to update, and other info, just to make sure that there's no any major changes, breaking changes into your pipeline. So usually when you have these tools, obviously you have your suite of tools, and if it's passing, if it's green, then you can merge. Another tool that could also do it, Snyk, and again, the most important thing in the sense for those components is to check the supported languages, just to make sure that it's actually covering your programming language. You can also potentially mix two, so you can use Renovate and Snyk just to make sure that you're covering all of the extents. Again, if you scroll down, this also is free for open source and public repos. Here's just an example of the web UI where you would import the project. They will scan and let you know if there's any vulnerabilities within your components. There's also a sense of a little bit giving you a little bit of context. So where is the vulnerability? Just a little bit more context on the security vulnerability. In that sense, this one was on prototype collision on Lodash. So what is prototype collision? If you want to have that education piece as well, and then you can click on the green button and fix the this vulnerability, because that's what you want. You want actually actionable fix, and this is the PR that you would have. They'll let you know which version you would update to. That's quite a major upgrade. But yeah, usually you have the merge advice. You'll need to double check with your pipeline and the workflow that you have in your test suites. Make sure that it's not breaking anything. You could have also the notifications. So by emails, there's an example with Dependabots on the left and Snyk on the right. You have those email digest, alert digest you can have like weekly or daily, like depending on your workflow. That was for the SCA. Let's move on to secrets sprawl definition. So secrets sprawl is the unwanted distribution of secrets like API keys and credentials through multiple systems. So we don't want our keys out there, especially because if we do work on open source components, it's obviously publicly available. So we can use a tool like GitGuard to help us on that sense. So if you navigate on the product page, you'll learn a bit more about how GitGuard works, but basically detects all of the secrets that you might have, and will let you know if you've actually pushed some secrets on your repo. Again, good news, it's free for open source. And for this one, because we're talking about capturing credentials and secret before pushing it to prod, I would recommend to select all of the repos just to have that historical scan. And then you can do by push. But obviously, the first time, just to have that historical scan, just make sure that you are aware if there's any credentials that you've pushed in the wild. And after that, make sure that you have a webhook. So before pushing to production, you'll actually be stopped on the terminal saying that you might potentially push an API key or credential. So this is what it looks like. So I've been using the OSP Juice Shop as a demo here. So it's vulnerable. It has also credentials, as you can see. So I've done the historical scan, letting me know that there are a couple of issues, a couple potentially credentials. It's letting you know which part of the code they've actually pushed some credentials. And each of these tool, they actually have a suite of integration, which is the expectation for developers, because we do want to have those options and alternatives. So you can see There's a lot of VCS integration options. So obviously, I'm talking about GitHub, but if you're actually hosting on different sources like GitLab or Bitbucket, you can actually serve also there. Depending on your CI/CD integration, so if you're using Circle CI, Jenkins, and others, but also for specifically for those credentials, I would recommend to have a pre-commit webhook. So before pushing to the repo, make sure that on the terminal you have that message. So be aware you're gonna actually push a credential or an API key. So that's for the secret scroll. The third layer is the static code analysis. Definition. So SCA is a method of debugging by examining the source code before a program is run. So it's done by analyzing a set of code against a set of coding rules. Again, there's a few vendors doing it. Let's have a look with Sonya Cloud. So also you can find either, you can use the application through GitHub Marketplace, or you can use the GitHub action if you want to automate all of these jobs through GitHub Actions as well. So once you've imported your project, the good thing with this tool, it's not only checking your main branch, but also the sub-branches that you can potentially work on. And this is what it looks like when you have all the results. So you have like what they call the quality gates. So it's not only a security tool, it's also, it will let you know about the, if you have any code spell, if you have duplicates in the code. But we're interested in the security block in a sense. So I'll let you know the list of security vulnerabilities. This is, again, using the ALS2 shop as a demo, as you can see, because it's a vulnerable app as expected. There are a lot of security issues. The good thing with this tool is because we still want to have that education piece. So if you click on one of these results, you will have a little bit more about the context of the security vulnerability and how to fix it. For those of you who love to everything around metrics, coverage, numbers, usually those tools, they do have heat maps and all of those by lines of code. So this is great if you want to have a little bit of more metrics around your project. Another good one is CodeQL from Security Lab at GitHub. If you don't know where to start, actually, you can actually trigger the workflow just by using their templates, because they've already pre-populated the template. So if you go to your GitHub Action tab on your repo, you'll have this, like get started with code scanning. You set up the workflow. It will actually scan and analyze your project. Here, in that case, again, we're using the ALS2 shop demo, which is using both JavaScript and Python. The good thing is it's actually detecting JavaScript and Python. It's really small, it's in the bottom. Just double check if it's actually determining the correct programming language, and then you can just commit this, and it will trigger the jobs. Here you can see both the JavaScript and Python jobs. So doing the scan exercise, and then you'll get all of the results. This is using serif formats, but as you can see, also it's like a lot of hard-coded credentials. Again, so quite a few findings. If you click one of them, it'll give you a little bit more info on what is going on, just giving you the context. So you can see there's like patterns in this tool. So as I mentioned, just choose the one that is actually fitting your workflow or your team. So how does it work on GitHub? Because you might say, Sonya, that's great. Like you're showing a lot of tools, but how actually does it work on GitHub? That's a good question. So when a contributor is raising a pull request, usually it will trigger all of the applications and actions you have implemented into your pipeline. So if you scroll down your pull request, you will start seeing all of these little widgets popping into your pull request. So here we have Gatsby for development. Here we have Solid Cloud for security. And we have perfect states there with everything, all the green checks. But this is how it looked like usually before you actually merge the pull request. So you can see all of the different tools that you might potentially implement within your pipeline. And this will depend on the threshold that you've set up within your team, or you want to set up as an example for your pipeline, your code base. And also depending on how it is implemented within GitHub, you might also have a look at the check tab, and you can have more information. If you don't want to go into the dashboard of the specific application, you don't need to. Everything is actually centralized within your pull request. You have all of this information. So how to get value from chat ops? First of all, let's define what is chat ops. So ChatOps is a collaboration model that connects people, tools, process, and automation into a transparent workflow. What it means is usually you can use a tool like Snyk, you can use a free Snyk account, and you can have your team of contributors discussing and having dedicated channels that you have that will help you having visibility on those specific tools and what is going on within your project. So you can do monitoring and setting up alerts. So having that exercise, because it's quite a vital piece where developers can help where to get the right info. This is what it would look like. So depending again on your workflow, how you want to configure and rearrange all of those. It's just an example with a few tools. The one with GitHub, you can actually see in real time the color change. So this is like checking the scan. The red looks like some issues, so which is good because the developers can actually see that something is wrong. There's like some security issues in that specific piece of code that we've pushed. So this is a good way to have that kind of feedback. Any documentation on GitHub? Yes, you don't need to use Jira, especially if you don't have any budget for that. So this is actually the same kind of templating that you could find as if you're using Jira or others. So when working on an OSS project, you can leverage the GitHub boards and projects to list all the tasks that you have to work on for a specific feature. You can use label, you can use, so it's not called epic, it's called milestones, but it's the same, and you can actually link those. The important thing that you have to do is on each PR, you have to use the proper label to attach it to the project on the milestone, just to make sure that it actually feeds back to the specific section. And you can see there's like a project's progress bar here. So it's the same as we'd expect from any of those project management platform. And they do have automated boards, so you don't have to actually touch the card. It will just flow through the board depending on the status. So before merging, when you merge, it will just go to the other column, which is cool. And this is also a way to feature the all the work that you're doing with your team of contributors. So we've seen what's happening on the GitHub marketplace and how we can leverage all those tools to help you creating a secure pipeline. Let's move on to a few best practices around open source software. So first of all, apply the least privilege principle. So this to set the base permissions here on GitHub on the member privilege section, so they can only clone and pull the public repo. And to give additional access, the maintainer will need to add them to teams or make them collaborators or individuals. So basically create teams, allocate user to add user to it, and allocate to specific repos just to have that granularity and specific permissions. Make 2FA mandatory for all maintainers. They can do so on the settings. If you don't do so, actually, by the end of 2023, GitHub will actually force by default this 2FA. So all users who contribute code to any of the repos will be forced to enable one or more form of 2FA. Review your project controls. So this is if you're using, for example, the Bots or CodeQL. This is where you would actually set up the settings. If you want to receive the alerts, if you want to be granular, if you only want to have a look at the critical and high, so this is something that you might be discussing with your team of maintainers just to have that visibility. Same with the actions permissions. What kind of actions you would like to allow within your project. So if you want to allow actions created by GitHub or those who only have the blue tick. And also you have this box where you can allow specific specified actions. So you would have like a list of vetted actions that your team is okay to use for this project. Protect your main branch. This is mainly to make sure to avoid any accidental deletion by a maintainer. And also this is coming back for for example, the compromised maintainers on GitHub. You never know if you get a victim of social engineering potentially. The malicious actor can delete your main branch, but also you can set up the required tick for the different tools. So this is how it would look like. You would have the required tag. Again, this depends on your workflow. If you want to actually turn your guardrails as blocker, so until it's not, unless it's not green, it won't actually pass and you won't be able to merge. So this is a discussion that you might have with your team before setting those required tags. Enable notification and alerts. This is to have visibility around alerting. So this is around Dependabot, if you're using Dependabot for GitHub. The other for notification, just make sure that you have the proper address and email address, so you actually are aware of all the notifications. Review the webhooks that you're using. So because I've told you that all of these tools are free, so you might be keen to use a lot of them, try them, but you don't do this actually hygiene exercise where you will remove the webhooks. So make sure that you remove the webhooks that you're not using anymore, because you never know if some of them get compromised. This will compromise your code base. So make sure to clean up those that you're not using anymore, to deny access, or completely remove them. So if you go to this like configure, just remove them from your repo, just make sure that you're not using them anymore. Yeah, this is how it looks like usually, because you will see the permissions, the repo access, and then the danger zone. You can just like suspend the installation or just uninstall completely the application. Review your security overview checklist. So this is more if you want to implement a security policy, a security advisory, if you want to enable the Dependabot or code QL, code scanning. So if you want to implement a security policy, they're actually giving you a template, so you don't need to create it from scratch. Also, you have the security advisory. If you, this is more like due diligence. If you find any security vulnerabilities in another repo, you can actually raise a security advisory on it. Review open source checklist. So this is not related to security, but it's just because we love open source and we want to be a better contributor. So make sure that you have a description, a README file, a code of conduct, contributing file license. And if you can also issue, have an issue template, a pull request templates. So this is great for attracting new maintainers, just to have those within your repo. Implement open source workflow. So first interaction, this is when the maintainer pushes for the first time into your code base. Yeah, just like you can change the message saying thank you for contributing. This was your first push. So you can do it with the GitHub action, which is cool. Also another one which is cool is the close stale issues. So if you're not using, if you haven't actually taken a look at specific issues or PR, they will actually close it automatically. And also GitHub have this at the top telling you that, for example, here some of your issues appear to be stale, which is great. Also have this cleaning exercise within your code base. Finally, showcase your open source project status. This is what it looks like. So this is actually a good way if you want to attract more contributors to your project. So this is a good way to showcase the health of the different tools that you're using. And this is actually like a perfect state because everything is green. This is great, but yeah, so you could use the little label and tags that these application actions workflow will provide, and you can add it to the top of your README file. So this is two things, like just be proud of the work that you're doing, but also to attract new maintainers, just to showcase that your project is actually doing great. So usually you have those into the settings where you can copy paste the markdown, or you can just create a status page and just edit. So this is what it would look like at the top. This is the markdown format, and at the bottom, this is what it would look like at the top of the your README file. Different things. Check add licenses. This is an important one. So here, if you don't know where to start, actually there's a link to help you which license to pick. Once you've decided which one you want to pick, it's actually pre-populated. You only need to change a couple of things. So for example, here I've selected MIT license, and I only need to add the year and the name, which is great. And finally, check the website score. So this depends. This is not for those who are working on components, but more on website, and they wanted to open source. Just make sure that you actually check those. So you can check with Google Lighthouse to make sure that it's actually performing and have good best practices. You can also use page speed insights, or you can also scan your website with the Mozilla Observatory just to make sure that it's actually working properly. So before closing this, I'd like to give you 5 top tips for all the OSIS maintainers. So first of all, try to adopt the DevSecOps approach. So this is the shift left approach. This aims to detect security issues from day one in order to prevent security problems to begin with and to resolve them as quickly as possible if they do indeed arise. Secondly, address open source vulnerabilities. So we love open source components, tools, framework. Unfortunately, some of them can expose us to significant vulnerabilities. So while we're using OSS, we need to actually have ongoing monitoring for vulnerabilities, make sure that we regularly update and patch if there's any vulnerabilities. Third, automate simple security tasks, because we don't want to waste time on a manual task. So automation is really important, and we've seen it with a few of these tools. We can automate using the GitHub Actions. So all simple tasks should be automated, just because we want to focus on more interesting and more challenging tasks. Fourth, be aware of your own assets, because visibility is the first step towards gaining insights into our repo and our states. So you can't secure what you haven't identified, in a sense. So knowing precisely which assets make up your application and software production infrastructure is key, even if it's not on the organization level, but even if you're maintaining an open source project, it's also important. And finally, security training for developers, because developers are responsible for pushing code into production. So it's critical that we do receive proper training and understand a bit more about security. The important thing is that the training should be tailored to the specific need of the developer's role. So some key takeaways, I'll close on that. So the first one is open source can be a vector for large-scale cyber attacks. So we've seen it with open source components, such as the Apache Log4j, the open source Java package that was used to support activity logging in many of the JavaScript application in the ecosystem. So while we know that not all of the software written in Java were vulnerable, the affected package was widely used by developers, and there are many applications and services that actually suffer from this and have been affected and impacted. Leverage the application available on GitHub Marketplace. As you've seen, if you're a maintainer or contributor, it's quite easy to set up even like a basic pipeline with those 3 steps, and you'll have a good starting point actually to cover it. So yeah, create a small pipeline and harden the security of your project for your collaborator. I know sometimes like setting up can take a little bit of time at the beginning, but on the long term, you'll see the effect. So yeah, as maintainers and contributors, don't hesitate to actually experiment and make sure that you're using the right tool for your team. So experiment, but most importantly, do not push your keys on GitHub, please. If there's only one thing you remember, this one is really important. So I've written a handbook on this topic because I know I've only have like 30 or 40 minutes to cover this, but if you want to learn a bit more, I actually wrote this article which go in more in depth and give a little bit more advice on that sense. So I'm Sonya Moisset. I'm a senior security advocate here at Snyk. I'm passionate about DevSecOps, cloud security, and open source. I do a few things outside of Snyk, which I'm not going to bother you, but if you want to connect, you can connect through LinkedIn at Sonya Moisset. And yeah, just wanted to say thank you and stay safe in your journey to open source security contribution. Thank you.
Also hi iceberg and something about the last layer of coding. I'm doing some training. If anyone does have questions for Sonya, she is on our Discord server for anyone watching remotely, or again, you can get her on Twitter, LinkedIn, Smoke Signals. She answers to them all. Don't hide them in a GitHub repo though. And thank you very much.
Thank you.
So thank you everyone that is here and that's made their way out to our office today. For everyone online watching, if you are based in the UK, We meet in the Snyk offices once every 2 months. So come and join us, have some beers, some drinks, some soft drinks. If you're watching virtually from afar, thank you so much. Obviously, DevSecCon live streams all their sessions from all 21 chapters globally. So you get to learn everything from what's happening into Brazil all the way across the pond into all the way to Australia. So if you are looking for a local community, please look at DevSecCon.com. And then finally, just a reminder that DevSecCon 24 is happening on the 27th of June, completely free event. As I mentioned before, it follows the sun, so 24 hours of non-stop DevSecOps content. It should be a lot of fun, lots of giveaways, prizes, live posts. Hopefully it won't be your normal boring Zoom webinar, but join us and you can find all the details on DevSecCon.com. But thank you so much, and thank you all our speakers and everyone that's here today.
We've got any empties? Take over.
Oh, yeah.